This video will show you how to graph a logarithm. Number one, graph y equals 2 to the x and y equals log base 2 of x on the same set of axes. Show all work in the space below. Just like any other curve, whenever you're asked to graph, you should always show a table of values. So I'm going to set up an XY chart for y equals 2 to the x, and I'm going to set up another one for y equals log base 2 of x. For both charts, I'm going to use the calculator to help me find points. Now notice that the domain was not given from the start, which means you have free will. You could pick whatever you want using the calculator. So head over to your calculator and type in y equals 2 to the x and use the table of values. Okay, you might have to adjust your window like I'm doing right now so that you see points that make sense and that are easy to graph. So I'm going to use x equals a negative 3, and I'm going to go all the way to x equals positive 3. I'm going to jot down exactly what I see. I'm going to make sure that I write it down carefully. Make sure that your x's and your y's match up appropriately, otherwise your graph isn't going to look right. And now I'm going to put that off to the side. Folks, I chose a piece of graph paper that did not have arrows drawn on the ends, and the axes were not labeled either. So if you could just get into the habit, whenever that happens in the future, of drawing arrows and labeling your x and y axes, that would be wonderful. And you're going to take the points and you're going to plot them to the best of your ability. Now, obviously, some of them are decimals, so you're going to do the best that you can. The first graph, folks, is nothing new. We graphed exponential equations in the last chapter. So what you're seeing created on paper should look very familiar to you. You were not given the domain. You chose it yourself, which means when you connect these points, you need to put arrows at the end. And just a reminder from last chapter, folks, this graph gets really close to the x-axis without actually touching it. So y equals 0 serves as an asymptote for your exponential function. Okay, so hopefully all of that looks familiar. That should be review for you. Okay, once again, make sure that you have an XY chart that's legible. You want to make sure that you're using the correct points when you graph. You should be getting the exponential curve that we're familiar with. And you should be putting arrows on the ends because we've chosen our own domain. Okay, now what you're going to do is you're going to graph y equals the log base 2 of x. Now don't forget, folks, on your calculator there is a log button, but that's a log base 10. We need a log base 2. So there was a trick that I've shown you in the calculator. You're going to go into your y equals screen, and you want to get the log base trick. So hit math and hit your up arrow twice. Okay, you should see log base there. And you're going to put in a 2 and an x. Now the numbers in this table aren't going to be as pretty. Okay, you're going to see a lot of errors. Okay, there's a reason for that. So copy down, just a few points. You can even put 0 and put an error next to it. We're going to find out what that means in a minute. But I'm going to use 0 through 6. And I'm going to carefully jot them down. Okay, don't round. Okay, it's just a few extra decimals. Just jot them down. And then when you're done with the calculator, you can set it to the side and you can plot your points. Now notice how when x is equal to 0, there's an error. It means that this graph is not going to hit the y-axis at all. But it is, however, going to go through the points that you have listed on your table. And you want to plot them to the best of your ability, folks. Now you might be curious as to what this is technically going to look like. What you could do now is you could go back to the calculator and you can hit graph. Okay, and the calculator will create that picture for you. You can see from the graph that this is going to go up and to the right, but it's not going to get steep towards the end. It's going to start to level off a little bit. And it's going to get really close to the y-axis without actually touching it. Okay, the reason why is because there's an asymptote at x equals 0. Okay, so get really close to the y-axis without actually touching it. Okay, I kind of slipped up a little bit, but hopefully you get the idea there. Okay, it shouldn't be touching the y-axis. Okay, now these graphs look really interesting. So let's see if we can answer the next few questions. I'm going to slide this up a bit so you can see. The graphs of y equals 2 to the x and y equals log base 2 of x are symmetrical to each other with respect to a line. What is an equation of this line of symmetry? Well, I'm hoping that you guys recognize something that we talked about in the functions chapter. There seems to be a line of reflection that's cutting through the middle right here. And hopefully you guys are thinking to yourselves that you know what the equation of that line is. It's actually the line y equals x. And the reason I bring up the functions chapter is because when we were doing the functions chapter and we had two graphs that were reflections of one another over the line y equals x, they had a special relationship, those two graphs. And I'm hoping that you're thinking that relationship right now in your head, and I'm hoping that you're saying to yourself it means that they're inverses of one another. So what does this mean about the two equations above? They are inverses. Okay, we learned in the functions chapter that inverses are reflections of one another over the line y equals x. I'm even going to go up to my graph and I'm going to label that line y equals x. Okay, now I used a different color. I know some of you have different colors that you can draw that with. I also drew it in as a dotted line, so that will separate it from everything else. But you should also get into the habit of labeling all equations that you're graphing. This is the exponential function, and this is the logarithmic function. Okay, so put all your labels down. Now the next part of number 2, determine the equation of the inverse of the function y equals log base 2 of x. Well, this is the original, and we know to find the inverse we have to switch x and y. So it's x equals log base 2 of y. Now to me that's not good enough. I'm going to want to take that and I'm going to want to put it in exponential form. So this is my base. I know this is backwards from the way that we're used to seeing it, but a logarithm is an exponent. This is your exponent, and then by process of elimination, folks, I've used the 2 and the x, it's equal to y. This is the second equation that we drew. Okay, so graphically, they're inverses because they're reflections over the line y equals x. Algebraically, they're inverses because if you take the inverse of one equation, you end up with the other one. Okay, and this is why we do exponents and logarithms back to back, because these chapters are inverses of one another. All right, question number 3. I'm going to have to slide this up a little bit, and you're going to lose the graph on the screen, for me at least. You have it in front of you. What quadrants is each graph drawn in? Well, the exponential function is this one right here. It's in quadrants 1 and 2. Okay, and that's nothing new. We learned about that last chapter. The logarithmic function, however, is in quadrants 1 and 4. Okay, don't forget they go counterclockwise starting in the upper right-hand corner. So this is 1, 2, 3, and 4. Okay, and for exponential functions and logarithmic functions in their most simple basic form, it's going to be the case that exponentials are always in 1 and 2, and logarithmics are always in 1 and 4. All right, now we're up to number 4, and I'm going to see if I could sneak it in here, and you can still see the graph. Folks, the y-intercept of the exponential function is where y equals 2 to the x hits the y-axis. It's at the point 0, 1. The x-intercept of the logarithmic, it's where it hits the x-axis. Folks, that's the point 1, 0. And this just strengthens the arguments about inverses. We know inverses are when you switch x and y, and that's exactly what just happens with our y-intercept becoming our x-intercept when you switch x and y. Okay, if you would like to pause the video at this point, just in case somebody needs to copy down some notes, that would be wonderful. And then I'm going to start on the next side of the sheet. So you don't have to flip your sheet back and forth. I just found a nice picture on the internet of the same thing that we just graphed on the other side. And now I want to talk about domain and range. Don't forget that domain is your set of x values and range is your set of y. For your exponential function, which is right here, your domain goes from the left to the right, hitting arrows for both. So that's negative infinity to positive infinity, or it's all reals. The range, however, is a little different. It goes from the bottom to the top. Excuse me. We know the bottom hits y equals 0, or it doesn't hit, it gets really close to it. It's an asymptote. So it's going to start at 0 without touching it, but it's going to go all the way up to infinity. Folks, it's going to keep going up. And then for your logarithmic, this one's different. We haven't seen this yet. It's getting really close to the y-axis without actually touching it, and it's going off the side of your paper. So it's going to go from 0 to infinity, and then your range is going to go from points really low to points really high. It's going to be all reals. And once again, this makes total sense to us. Because they're inverses, it makes sense that the domain and the range could flip-flop as you move from exponential to logarithmic. Just got to make sure that you are aware of the x's and the y's. Okay, so domain and range from the two pictures that we graphed on the other side. Okay. Now down here, I want to make sure that we cover how to graph y equals ln of x. Okay, you haven't seen ln up until this point, but all ln is the natural log. It's a logarithm with a base of e. So these two are actually exactly the same. You could put it into your calculator either way. For me personally, I think putting in ln of x is so much easier, and here's why. There's an ln button on your calculator. It's right below your logarithm button. So you're going to put in ln of x. You don't even have to close the parentheses. I'll just do it to be a good mathematician. And then you're going to go to your table, and then you're just going to copy down points like we did for the logarithmic curve on the other side. So let me see if I can slide this over a bit. Have my calculator handy. I'm going to do a nice XY table. You can use 0, 1, 2, 3, 4, 5, and 6 again. Okay, sorry, it's sliding off the paper there. And I'm just jotting down what I see on the calculator. Okay, don't rounds. Rounding here could be significant enough that it alters your picture a little bit. And it only takes a few seconds to jot down everything that you need. And then go back into your graph and put arrows, x and y. And now I'm going to slide everything back over just a little bit so it fits on the screen, and I'm going to start to plot those points. Okay, now don't forget this is a natural log. It should look basically the same as log base 2 of x. So it's 0 error, so we know it's not hitting the y-axis. 1, 0. 2 and 0.69. I'm going to stop saying the points out loud so that you can concentrate and get down what you need. Okay, once again, they did not give us the domain. We've chosen what we wanted to plot. So for that reason, we need arrows. And what you're seeing here, folks, is a graph that's very similar, like I said, to log base 2 of x. Still quadrants 1 and 4. Still an asymptote at y equals 0, or rather x equals 0. There's a domain that goes from 0 to infinity, and the range goes from negative infinity to positive infinity. All right, I hope you enjoyed this video.